Hey guys, today we are starting Module D, and Module D is all about rational functions. And in the second video over 8.3, I'll talk more about what a rational function is, but just to get our feet wet and get introduced to the module, we're going to talk about what a reciprocal function is. So you've heard the word reciprocal before when we're talking about fractions, and that's exactly what this function is going to look like. So with the reciprocal family, the general form is highlighted right there, y equals a over x minus h plus k. And it says here where x cannot equal h. And obviously x cannot equal h because what would make that denominator go to if x were h? It'd make it go to 0, that's right. So if I have my denominator at 0, I wouldn't be able to graph the function. So as you can see to the right, this is the parent function, y equals 1 over x. And we're going to talk about why that graph is jumping the way it is. We kind of just talked about it a little bit already, but we're going to dive into that more when we do some examples. So before we get started, let's talk about the domain and the range. The domain of a reciprocal function all depends upon that denominator because we just talked about you can't divide by 0, right? So for our parent function, the domain would be all real numbers except when x equals 0. So we're talking about this parent function here. Same thing for the range. It's going to be all real numbers except when y equals 0. Now, when I do some examples in a second, I'm going to show you that it's not always 0, okay? It is for the parent function here, but it isn't always going to be 0 when we start looking at other examples. You're actually going to see that my domain restriction comes from whatever h is. And my range restriction is going to come from whatever k is. And we will see that in just a second. So just like before, okay, we've used a, h, and k many a times. We've seen it out through all 3 modules now. And you see it here again with reciprocal functions. That a value on top tells you whether you have a stretch. They call it a shrink here. Okay? You know it as a compression. All right, and remember if that a value on top is negative, it's a reflection over the x-axis. So that h tells you your horizontal transformation, and again, it's the exact same thing that we've looked at. Okay, that x minus h, we've been looking at that for a while now. And that k value tells you your up or down transformation. Now, there's a new word presented here. It's called an asymptote. Okay, this new word right here. We talked about on the last slide about how h is your restriction. And the reason that is because you can't divide by 0, right? So that restriction of h is called a vertical asymptote. Think of like those invisible dog fences, right? Like the dogs wear the collars, and the dogs get super, super, super close to that invisible fence, but then as soon as they cross that line, you know what happens, okay? So think of a vertical asymptote and a horizontal asymptote kind of like that. It's this invisible line that is your restriction that your graph cannot cross. So really important here, your vertical asymptote is the line x equals h, and your horizontal asymptote is the line y equals k. And like I said, I think this will make a little bit more sense once we start doing some more examples. So again, down here at the bottom, what does my combined transformation form look like? Right here. The a tells you whether you're stretching or compressing and whether you're reflecting. The H tells you your shifts horizontally, and it also tells you your vertical asymptote. And the K tells you your vertical shift, which is your horizontal asymptote. That's really confusing. So take a second. Just work on that right there. All right, so let's start putting some functions together on a graph. So here we're just going to start out simple. We're going to graph the line y equals 6 over x. I notice here that I don't have any h, so if you want to put that plus 0 there, and then I also don't have any k. So that'll help me talk about the domain. It would be all real numbers except x equals 0, and then the range too, all real numbers except when y equals 0. So what does this mean? This means your vertical asymptote is the line x equals 0, and your horizontal asymptote is the line y equals 0. So I'm going to go ahead and put in my vertical and horizontal asymptotes. And they are on the axis. And that's going to be the case for all three of these examples if you look down at B and C. So I went ahead and just graphed them in that coordinate plane for all three of them. So here we go. Let's start graphing. Now, for this first one, what would be some good x values to plug in? Whoops. I'm thinking some good x values would be like x equals negative 6, negative 3, negative 2, negative 1, maybe 1, 2, 3, and 6, okay? I'm using values that will divide nicely with that numerator. So for instance, I wouldn't want to use like 5 or negative 5 or 4 or negative 4 because those would give me some crazy fractions. So I'm going to go ahead and plug in any of those points, okay? And we're going to go ahead and graph. So you can see after we graph that first one, it already has those natural jumps where those asymptotes are. Because we talked about earlier, we can't have x be 0, so we have that vertical asymptote at x equals 0. And then that also presents that horizontal asymptote of y equals 0. So you can see you got two sides to this graph, okay? Same thing with B. You notice here that you don't have an h value, nor do you have a k value. So this makes the domain and range very easy. All real numbers except x equals 0. Range is all real numbers except y equals 0. Will we ever see that change? Yes, just for now though, we don't have them there. Vertical asymptotes. X equals my h value, which is 0. Horizontal asymptote, y equals my k value, which is 0. Okay. Now here, let's talk about what are some nice values that we could plug in to use for x. That's right, we could plug in negative 5. That would give me 1. We could plug in negative 1, which would give me 5. Okay, that's pretty much all on that side. If I plug in 1, I would get out negative 5. If I plug in 5, I would get out negative 1. So here we were kind of limited on our points that we could plug in. However, you technically only need 2 points on each side of that vertical asymptote. So I have 2 points to the left and I have 2 points to the right. And we notice here the graph is in opposite planes. Why did that happen? That happened because of that negative that we see here out front, okay? It flipped it over the x-axis, so what was in our pink for A is now flipped for B. Okay. On C, we're doing the same thing. You know what the domain range vertical asymptote and horizontal asymptote are. Those are all the same. All right. So here, let's talk about some nice numbers that we could plug in for x. Okay. Nice numbers we could plug in for x. Do you want to use fractions? You totally can. If you're comfortable using 1/2, I think it would be safe to use that here. If you want to use like -1/2, you would get out -1. Okay. If you want to use -1, you would get out -1/2. Okay. Same thing with the positives. If you want to do +1, you get out +1/2. If you want to use 1/2, you would get out 1. And again, we're going to use those asymptotes as our guide for graphing. Okay. You want to use those asymptotes for graphing. Last thing I didn't talk about that I need to talk about are transformations. On this first one, you would have a stretch by 6. The second one here, you would have a reflection over the x-axis and a stretch by 5. And then on this last one, you would say it was compressed by 1/2. Now, I want you to take a second and I want you to look at all 3 of these graphs on the same coordinate plane. Okay? What is something that you notice between that A value and how the graph looks? There's something going on with the larger the A value, something's happening with that graph. Okay? Now you'll notice the larger the A value, the farther away the graph is from the origin. You can see that pink and that maroon graph, that 6 and that -5, are very far away from where the origin is. But on C, where we graphed a 1/2 over x, it was very tight next to that origin. So just kind of a thing to notice here, the larger that A value, the further it is away from the origin. So on this next example, I want you all to start looking at when x minus h is not necessarily 0 and our k value isn't necessarily 0. So on problem number 3, what is the graph of y equals 1 over x plus 1 minus 2? Identify the domain and range. So here we have an h, we have a k that we need to look at, okay? So for our domain, we would say all real numbers except when x equals -1. Where did we get the -1 from? It's going to make the denominator go to 0. Okay, that's where I got that -1 from. So what's my restriction? I can't have the denominator go to 0. So that means I can use any number except -1. Now for the range, this would be all real numbers except your k value, except when y equals -2. Now, what your restrictions are for your domain and range tell you what your vertical and horizontal asymptotes are. Your vertical asymptote would be x equals -1. Your horizontal asymptote would be y equals -2. So before I start graphing, let's talk about our transformations. We would say we went to the left 1 and then down 2. So over here, you can say you went to the left 1 and you went down 2. That's where your asymptotes are. Okay. Did I stretch it at all? No. Did I compress it at all? No. My A value up top is 1, so I don't have any of those transformations here. All right. What would be some good X values to plug in order to graph? Well, I think a good X value would probably be -2. Because when I plug in -2, I get 1 over -2 plus 1, and then -2. So that would give me -1 minus 2, which gives me -3. So let's plot the point -2, -3. I could also use 0. That would be a good point. 0 would give me out -1. Okay. Could we keep plugging in values? We totally could, okay? But essentially, all you need is 1 point on either side, and then you have your guide as the asymptotes to help you graph. So here, I could go ahead and just say, this is my graph. This follows a rough sketch, and this is completely fine for what we're doing. So on number 3, if you want to, go ahead, try it on your own if you feel comfortable. See if you can list the domain and range. Maybe list the asymptotes as well. So for my vertical asymptote, I got 4. And then for my horizontal, I got 6. I did not go far enough. All right. So again, let's talk about the transformations. We went to the right 4, and we went up 6. Same transformations like we've been using this whole semester, guys. And we can see that in our vertical and horizontal asymptotes. Okay? So what would be some good points to use here when I graph? Well, what's going to make that denominator pretty nice? I'm thinking 3. Because 1 over 3 minus 4 would give me -1 plus 6. That would give me 5. And then maybe let's use 5. Because 1 over 5 minus 4 would give me 1 plus 6 would give me 7. And then I can sketch my graph. And I'm done. For those of you who can pick up on what points to plug in, just to verify you, plug in X values on either side of that vertical asymptote. So in this case, our vertical asymptote was at 4, so it would be really nice to plug in 3 or 5 because my A value is 1. If your A value wasn't 1, it wouldn't just be 1 on either side. If that didn't make sense, totally ignore what I just said. Keep using values that work nicely for your fraction here. All right. I would love for you all to try to do these 2 on your own. So if you want to, go ahead and pause the video and try to work these out on your own. If you need some more assistance, I'll go ahead and walk you through these. So we notice we have an H and we have a K. So for our domain, that's all real numbers except x equals 1. Range would be all real numbers except y equals 1. So that means my vertical asymptote is x equals 1. My horizontal asymptote is y equals 1. So we can talk about the transformations here before we start graphing. I went to the right 1. I went up 1. And my a value is 3, so that means I have a stretch by 3. So this is going to kind of affect what x values I plug in. So again, what would make this denominator nice? Because I have that 3 on top. I could plug in 0. I could plug in 2. I could even plug in 4. I could also plug in -2. Okay? Where am I getting these numbers from? I'm getting them from what can 3 be divided by nicely? 3 over 0 minus 1 would give me -3 plus 1. That gives me -2. If I plug in 2, that's 3 over 2 minus 1, which is 3 plus 1 gives me 4. This would give me 2. This will give me 0. And I'm done. We're going to do the same thing on this next one. You notice down here you don't have an h, so if you want to put that +0, you're more than welcome to. So the domain is all real numbers except when x equals 0. For the range, we would say all real numbers except when y equals -1. So my vertical asymptote is x equals 0. My horizontal asymptote is y equals -1. So vertical at 0, horizontal at -1. Transformations, let's talk about those before we graph. I didn't go left or right any, but I went down 1. I reflect over the x-axis. And why do I do that? Because I have a negative a value. And then I stretch by 2. So from here, what would be some nice values to plug in for x? I can pretty much plug in anything except 0. So we could do -2, we could do -1, we could do 1 and 2. Those work out nicely. -2 over -2 is 1 minus 1. That gives me 0. That would give me 2 minus 1, which is 1. -2 over 1 minus 3. -1, -2. So -2, 0. -1, 1. 3 and 2. Again, why is this graph flipped? Because that negative out front reflected it. Okay. I hope you all are catching on to this fairly quickly. If not, please rewind and watch the video. Again, go back on our Canvas calendar and you can walk through the textbook pages if you think that might help you. And there's always YouTube. There's other additional videos that can help. Let's do these last couple of examples and then we will be done with reciprocal functions. So on problem number 4, it gives you the equation y equals 2 over x, and it gives you the asymptotes, and it wants you to create the equation. So looking at the graph, be extra careful. The axis goes by 2's. So please, please, please make sure you're paying attention to that. So let's talk about the vertical asymptote quickly. my vertical asymptote would be at x equals -3. And my horizontal asymptote would be at +4. So when I write my equation, remember it's y equals a over x minus h and then plus k. So the equation here would be y equals 2, where did I get the 2 from? Original equation. 2 over x plus 3 and then plus 4 out to the side. This ties in nicely with what we know about transformations. Remember, it's always the opposite of what our original was. So I know what you're thinking. Is this your final answer? Yes, this is your final answer. All you had to do was create the equation looking at the horizontal and vertical asymptote. Last problem, here we go. Same thing. Let's look at the graph and let's identify our asymptote so we can create our equation. Go ahead and try this one on your own. If you need me, I'll be right here. Looking at this graph, you notice it also went by 2's. Be extra careful there. We notice our vertical asymptote is at x equals 1. Our horizontal was at -4. So again, when I write this in final form, I would have 2 over x minus 1, because it's the opposite, and then -4. That is all I have for you on reciprocal functions. Now go ahead and you can either work on the 8.2 homework, or you can go ahead and watch the 8.3 video.